unit in math, we're usually referring to the number 1, like a single unit. So when we're talking about the unit circle, we're talking about a circle with a radius that is equal to 1. So only circles with radius of 1 are unit circles. They also have to be circles that have centers at 0, 0. Which means that the equation for a unit circle is simply x squared plus y squared equals, and it should be r squared. R is 1, and 1 squared is 1. So x squared plus y squared equals 1. And I'll draw myself a little picture of a unit circle. You know, as you go all the way around any point on the unit circle, it's going to have that radius of 1. Now, you might look at the unit circle that's not totally filled in front of you. Of course, you filled in the angles in degrees and radians. Okay, so we know the angles. But you'll also notice outside this circle, there's a place for coordinates. So we're going to be naming some of these xy coordinates that happen around the unit circle. But there's infinitely many points on that circle. We're just naming the ones that are part of our special right triangles, 30, 60, 90, and 45, 45, 90. There are some points on the outside of the circle we could label already, though, right? What's the ordered pair for this point on the positive x-axis? If the radius is 1, I'm going right 1, up or down 0. So if you want to on your unit circle, your sheet, go ahead and label that 1, 0 to the right. Then I can label this point right up here on the positive y-axis. That's going to be 0, 1. Negative x-axis is going to be negative 1, 0, and negative y-axis is going to be 0, negative 1. So we do know 4 of the points already, just based off of the definition of the unit circle. So if you want to fill those in now, you can, or I'll have them on the screen a little bit later. Okay, now you might have noticed my triangles in the back there. Those are going to be the triangles that we're looking at in our unit circles. So I also have something similar on my screen up here. I put those in the back because I really want to stress this idea of, I call them bow ties or butterflies. So all through Chapter 4, Chapter 5, Chapter 6, when we're doing all this trig, when we're talking about angles in the coordinate plane, they need to be angles that are part of bow ties or butterflies. Never should you ever be drawing triangles that make hourglasses or diamonds, where the right angle would be at the origin. Okay? Your goal is to have your right angle on the horizontal axis. So if you look at the back, you're going to see all those right angles are always on the horizontal axis. Okay, so bow ties and butterflies. This is also, if you're thinking ahead to like, I'm supposed to be responsible for knowing the unit circle, and I'm supposed to know all those angles in degrees and radians. And I kind of talked about this on day 1. But using the reference angles would be really helpful for you, other than looking at patterns. So like, this is pi over 6 or 30 degrees in the purple. And then this angle in quadrant 2, this is 180 minus 30, which was 150, or 1 pi minus pi 6, which is 5 pi 6. And then when I want to get the one in the third quadrant, I would add the 30 or add the pi 6, so this is 7 pi 6. And when I want to get the one in the fourth quadrant, I subtract it from 2 pi. So 2 pi minus a pi 6 would be like 12 pi over 6 minus pi over 6, which is 11 pi over 6. So if you're struggling with like, how am I supposed to remember all of those angles, I think using the reference angles is a good tip to use. Okay. Okay, so that's the idea that we want to focus on, but I have to clean up one thing. I don't think you have to write this first part down because you should have it in your notes from yesterday's warm-up. Okay, but we reviewed the special right triangles, and you agreed with these ratios for side lengths. Okay. When you look back at the back wall over there, all those right triangles, they're part of my bow ties. Notice the hypotenuse is going to represent the radius of my circle, right? So I'm going back also to this slide right here. I got that circle sketched there. If I want it to be a unit circle, then I need all of these hypotenuse to be equal to 1. But when I look at the right triangles as we did them yesterday, I got a hypotenuse of square root 2, which is like 1.41, a hypotenuse of 2. So what we want to do is basically we're going to use this idea from geometry, similar triangles. We're going to scale our triangle down with a scale factor. Scale factors are basically multiplying, but if you're dividing, it's like multiplying by a fraction. Okay. So if we have square root 2, and we want it to be 1, we're going to divide by square root of 2. So the rule of scale factors back to geometry is then you have to divide all the sides by square root 2 so that they all stay proportional. Okay. Now I'll have a hypotenuse of 1, and on the 2 legs I'll have to rationalize my denominator and multiply by square root 2 over square root 2. I'll move this up. And this is, if you look at your tables, you've got that pink triangle out there. The pink triangle is labeled like this because it fits the unit circle. It has a hypotenuse of 1 because that's going to be my radius. And then its side lengths are going to be square root 2 over square root 2. So if you do want to draw those in your notebooks, feel free. You can copy the pink and the green triangle at your pods, okay? Or you can copy from the board. Now, we technically should have to do that with the 30, 60, 90 triangles, but instead of dividing by square root 2, we'll just divide by 2 for everything. So that's nice because then I don't have to worry about rationalizing anything. So this should look familiar as well from Algebra 2. These numbers should sort of ring a bell. So these are the same things that are on the green triangle. You know, these two are really the same ones. You'd only need to really write one of them. But we're going to be orienting them differently, so we'll have the yellow bow tie and the green bow tie on our unit circles. Okay, so this is the last bit besides when we get to, when we finish the unit circle. This is the last bit in the notebook. So we're going to switch over to our unit circle now. You got that worksheet in front of you. Okay. You got the angles all labeled. You maybe have labeled the 0, 1, 1, 0, 0, negative 1, negative 1, 0. If you haven't labeled those yet, maybe do that. And then I also labeled the quadrants. I mean, it's just helpful to know what quadrants are what, but if you already know quadrants really well, you'll be okay. So I labeled the quadrants. Okay. So what we're going to do is we're going to identify the families of special right triangles within the unit circle, and hopefully as we do this one at a time, you're going to notice some patterns that will make it really easy for you to come up with the unit circle for quizzes and tests when you don't have it in front of you, right? It's your job to know the unit circle. Okay, so take a highlighter. It can be any color. Take a highlighter. And we're going to highlight the 30-degree reference angle bow tie. So what I do is I just start up here at 30, and I follow that line all the way to 210. And then I find in quadrant 2, that would be my 150 follow that one all the way to 330. Sorry for my wonkiness. And then to close the bow tie, it will make my right triangles. I just connect those two sides of the X's. Okay, but notice I'm creating a right angle at the horizontal axis. So you can take that and highlight. Now, I did put colored pencils out, so I'm going to come around just real quickly and show you. I like to lightly shade in my triangles just because I sometimes feel like when I have just the highlighter, everything looks like kind of crazy, and then this just makes my triangle stand out more to me. But this is your unit circle. You can do whatever you want. Good. Your bow ties are looking lovely. Okay, now, you don't have to take one of the green triangles, but if you're kind of more of like someone who wants to touch and see, you can grab one of the green triangles. I know there's not enough for everybody, but everybody can take their turn. If you take a green triangle, mine is pink, I'm sorry about that. And I resized mine, so of course it's a little bit big. If you take a green triangle, you should be able to kind of like fit it into that bow tie. And so what you're going to notice is the side length's going to match up so that the hypotenuse is your radius, right? 1, which is true because this is the unit circle. And then I now know the sides of this right triangle. So if I want to fill in this ordered pair for this point on the outside of my unit circle, my x value is square root 3 over 2, and my y value is 1/2. So now we can label that in. Square root 3 over 2 and 1/2. Now if you're like a visual person, you got that triangle right there. You could take that triangle and you could just reflect it over the y-axis. And then now what's my x? Negative square root 3 over 2. And my y is positive 1/2. If you need to see that, put the little green triangle in there. So I'm going left, I'm going to now label it a negative, but because I'm going up, it's still positive. What will happen when you reflect it over the x-axis then? What will be true of your coordinate? X and y will both be negatives. But won't it still be the same thing? I'm going left square root 3 over 2. I'm going down 1/2, so there's still x and y. Okay, so negative square root 3 over 2, negative 1/2. And then in quadrant 4, of course, it'll be positive square root 3 over 2, but a negative 1/2. So another thing you could add to this is, like on the outsides, just label that all the points in quadrant 1 are going to be positive, positive. All the points in quadrant 2 are going to be negative positives. All the points in quadrant 3 have to be negative, negative, so that I go left and down. And then all the points in quadrant 4 are going to be positive, negative. That's a nice little like pattern to notice. So if you can't remember which one's negative and which one's positive, just think about which quadrant it's in, and you know the rule. Okay, now I'm going to do the next one, which is the 45. So I'm going to pick a different color. I'm going to do the same thing, like highlight, and if you want to shade in, you can. My bow tie for 45s, or pi over 4. So I'm going to start at pi over 4, go all the way through to 225. Go all the way through. Okay, and then draw a vertical line so that you're creating right triangles. And if you want to shade it in, you can. If you're like super confused about what you're doing, let me know. If you want to pick up one of the pink triangles at your pods, the pink triangles are your 45, 45, 90 triangles, and you can try to fit that in. Remember that your hypotenuse has to be along that radius. Your right angle has to be on the horizontal axis. And my 45, 45, 90, too big again. Scale it down a little bit. Fits in right there in quadrant 2. But I can see my x and y values are going to be square root 2 over 2, square root 2 over 2, right? They're the same. So in quadrant 1, they're both going to be positive. In quadrant 2, I'm going to have a negative x and a positive y. Both negatives in quadrant 3. And you'll see it gets pretty messy up here on the smartboard. And a positive and a negative in quadrant 4. I wrote a 3. Okay. So when you're thinking about, okay, some days in class I'm just going to give you a blank unit circle and say, fill it out. Okay. When you're taking quizzes and tests, you won't have a unit circle. You'll have to, I wouldn't take the time to draw it out every time, but you have to be able to kind of like generate these things. What I always recommend is memorize the first quadrant and then just go by patterns for signs in the second, third, and fourth quadrant. Okay, and then you've got one more to do. I know some people have worked ahead, so highlight that last bow tie. You have to, if you're using those triangles, those cutouts, you have to use the green triangle again and fit it in. It's going to be very similar to those 30-degree bow ties, but what's the big difference in your coordinates? They swap spots, right? X and Y are switched. Because I'm just going over a little bit and then up a lot, and 1/2 is less than the square root of 3 over 2. Like 0.5 and 0.7. Okay, so I'm going right 0.5 and up 0.7. So fill those in. 1/2 square root 3 over 2's. So I really want to impress upon you this idea of the bow ties and the butterflies. You can make connections that, if you're doing these angles that are all part of the same bow tie, their coordinates are going to look exactly alike other than their signs. And the signs can be determined by which quadrant they exist in. Okay, so what good is labeling all these coordinates, right? That is the question. Why do I care? So we're going to go back to our notebooks, and we're going to fill in a little bit about trig, kind of like what you did yesterday, but it's going to simplify on the unit circle. Also a side note, when I post my video notes today for this, I'll post a unit circle filled in. So if you feel like, I'm not sure my signs are right, I'm not sure I got everything down, you can check it on my website or just Google a unit circle and you'll get tons of results. Okay, so here's the why. So you would put this in your notebook. We're going to make a definition of trig ratios on the unit circle. And one of the big difference in the definition is that in the definition I'm going to say sine of t, cosine of t, tangent of t, where like yesterday if you look at that half green sheet, it was thetas. And the only reason I'm using the t right there is because t is going to be an angle from the unit circle, whether it be in degrees or radians. And those are the angles that I referred to on day one as special angles. And they're the special angles that we picked for the unit circle because they're the angles produced by all those reference angles for 30, 45, and 60. So I'm going to draw this picture. I got my unit circle, let's say, right there. So just like I did before, for any point out here, x, y, my hypotenuse is 1, my radius is 1. And if I drop that side length down to the horizontal axis, that's my measurement for y. And going back to the origin, that's my x. And so my t is always happening right around the origin. This drawing will draw over and over again. Sometimes it'll be on the unit circle, so it'll be a 1. Sometimes it'll be any randomal circle, so it'll be an R. We'll see it so much throughout the semester. If I asked you like yesterday, so Katella, to give me the sine of t, we would do opposite over hypotenuse, or y over 1, which is just y. So the sine of t, an angle on the unit circle, is the y coordinate. And the cosine of t is x. It'll be x over 1. And the tangent of t is y over x. Okay. Those are really the three you need to know, right? Because if you figure those out, then you can do the reciprocals. It's 1 over y, you're just going to flip whatever you have, 1 over x, and x over y. Okay, so the big takeaway from this ordered pair that we just put on the outside of our circle, x is cosine, y is sine. So if I said, what's the cosine of 120 degrees? You just look at your unit circle. Cosine is x. So we would say negative 1/2. What's the sine of 5 pi over 3? That's in the fourth quadrant. Look down. Look at its coordinates. Sine is y. Is that negative square root 3 over 2? You don't have to do any work. So you have it memorized. You know it. You can do sine and cosine. Now, tangents. Maybe you have to do a little bit of work in the beginning, but hopefully we'll be able to fill in our tangents before you leave today. So you might even remember tangents from Algebra 2. Okay. Here's what some of your problems on your assignment are going to look like tonight. They're going to say, find the 6 trig ratios for t equals 5 pi over 4. Now, really, it could be a theta right there, right? It doesn't really matter if I'm calling it t or not. But the thing that you would recognize is 5 pi over 4 is on the unit circle. Find 5 pi over 4 on your unit circle. What's your ordered pair for 5 pi over 4? Negative radical 2 over 2. Negative radical 2 over 2 because it's in quadrant 3. And remember, this is cosine. This is sine. So evaluate the 6 trig ratios. Sine of 5 pi over 4 is negative square root 2 over 2. Cosine of 5 pi over 4 is also negative square root 2 over 2. And the tangent of 5 pi over 4, I can always do this one by hand. Hopefully we'll get to know tangents well enough that we don't have to. And like I said, hopefully we'll fill that out. Is negative square root 2 over 2 over negative square root 2 over 2, which is just 1. If I have those, I can easily do my reciprocals. Cosecant, secant, and cotangent. I'm going to do my workup at the top just because I don't have a lot of space. Wouldn't I just flip negative 2 over square root 2? And then I'd have to rationalize. So I get negative 2 square root 2 over 2. But then those cancel, so it's just negative square root 2, negative square root 2. Reciprocal of 1 is 1. I didn't really even do much work, did I? A little. Okay, do you remember this from Algebra 2? When you're in the other quadrants besides quadrant 1, there's always one trig ratio and its reciprocal that will be positive. Like in this case, it's tangent and cotangent. Do you remember the little rule, so how you know which one is positive in which quadrant? What did we say? It's a little phrase. All students take calculus. You ever heard that? Okay, so all of them are positive in quadrant 1. Students is quadrant 2. Sine and cosecant are positive in quadrant 2. Take, tangent, and cotangent are positive in quadrant 3, which is where this one exists. Okay, and then calculus is cosine and secant is positive in quadrant 4. So if you want to, you can add that to, want to go back. You can add that to your unit circle if that's something that you would like. It really goes with these positive and negative pieces. All students take calculus. Okay, it really goes with those positives and negatives. If you want to like actually write out which ones are positive and negative where it says that, you can. So like this one is tangent and cotangent are positive. Everything else is negative. Okay, oh yeah, I definitely have time to do my tangents. So I'll do this one, cosine and secant. This is nice if you know it, just because, you know, on a quiz or a test, you might forget a sign or something. And if you just like look at your answers at the end, you know, you wrote out sine, cosine, and tangent, and then you're like, wait, I know sine is positive in quadrant 2, so I'm just going to change the sign. I don't know why I got negative. Or my tangent ended up being positive because I was just careless, so let me just remember to put my negative down. So that's really nice. Okay, we already, because we did the 5 pi over 4 down here in quadrant 3 on that example, we already know the tangents of pi over 4s in quadrant 1. Square root 2 over 2 over square root 2 over 2, y over x is just 1. So the tangent of pi over 4 and 5 pi over 4 are positive 1, but if you were doing 3 pi over 4 or 7 pi over 4, it would be negative 1 because tangent's negative in those quadrants. Okay, does anybody remember tangents of pi over 6 or pi over 3? these numbers should seem familiar. Let's see, if I'm doing tangent of pi over 6, I'm doing y over x, that's 1/2 over square root 3 over 2, which is 1/2 times 2 over square root 3. So 1 over the square root of 3, which I have to rationalize. So all the angles, part of that butterfly, and on the board it's red for me, all of those angles, their tangents have the number square root 3 over 3. It's just whether it's positive or negative. Positive in quadrants 1 and 3, negative in quadrants 2 and 4. Now, does anybody remember the tangent for pi over 3? You don't remember? So then you do the work. Tangent of pi over 3 is y over x. That's square root 3 over 2 over 1/2. That's square root 3 over 2 times 2. So the tangent is square root 3. Every student should be sort of like, that's a little bit familiar. Because in Algebra 2, you actually did all the trig. You drew the triangles every time. Okay. But now that you're in pre-calculus, we're like, don't draw the triangle every time, just know the unit circle. Don't waste your time on triangles. They're always the same. Okay. So if you write those down, I would put those on my unit circle in quadrant 1. Okay. Remember that they transfer to all the other quadrants. You just have to decide if tangent is positive or negative. Tangent is positive in quadrant 1 and in quadrant 3, but it would be negative in these. You can also do the tangent of 0, because it would be y over x, 0 over 1 is 0. And then you can do the tangent of pi over 2. So that's 1 over 0. No good. So we say undefined. Okay, and now you know all the tangents around the unit circle. Okay. So again, I know it's really messy on the board right now. I will have my copy posted online a little bit neater because it won't be in the smartboarding. And you can also always Google a unit circle if you need to. You're going to find tons of information.